Good morning. My name is my name is Umokobi Richard. You're welcome to Umokobi Richard's Econometrics, and I'm going to take you on ordinary least square today. I know we've actually done the previous videos. We've taught how to import data. We've taught how to run the unitary test. We've also taught draw how to how to draw graphs, and I've showed you different interfaces in different tools you're going to use: the EViews, the R, the Python, the MATLAB, and the Stata. So in subsequent classes, those tools will further be used in running our analysis. So today we're going to dwell on the ordinary least square. And first and foremost, what I'm going to do in this ordinary least square, I'm going to show you how to download the data set. After downloading the data set, we'll do unitary tests, we'll draw the graph, and then we'll run the OLS. Then the next class will now do the post-elimination tests like the heteroscedasticity, the autocorrelation, and the serial correlation, autocorrelation, and the normality test, uh, and and other post-estimation tests. So I will take you all through those things we normally um, have when you're writing your research paper, or when you're making analysis based on that, or when you're writing your thesis, anywhere you find yourself. So first and foremost, let's go to the data set we're about to use. We have the broad money, the end period exchange rates, the ocean, there's OBB rates, which is currently called open repo rates, inflation rates, and credit to the private sector. Our data set will range from January 2008 down to um, down to down to sorry, I want us to see where it ended. Let me just make it faster. Down to September 2025. So it's the current data, which will enable us to make a interpretation or conclusion from our analysis. So based on that, the inflation rate will be the dependent variable. We want to see which of these determinants of exchange rates. Looking at this, you can actually know that this is actually the demand side of inflation. Which of these actually affects inflation? So we are not going to use government expenditure because the data it has don't have data back to January 2008. So I will just let else we can start from. We are going to start from January 2010. Okay, January 2010 is also not bad. Okay, we'll start from January 2010 so that we can include government expenditure so that we can be able to make more more interpretation from our data set. So based on this, what is M3? M3 is money supply. M3 tells you the amount of money in circulation. In Nigerian monetary aggregate, we have the M1, M2, and M3. It has, if you can read on that, M1 is, I think, is basically the more how when M1 is like money in circulation, which is actually more liquid, is the most liquid kind of a monetary aggregate, which is easily transferable to cash. It's cash you hold, and the cash you transact. It's definitely cash in second. But when you put M2, you're putting time plus saving deposit. So all those your money in your deposits in your fixed accounts, which is not really, you can actually transact, but it's not really liquid as M1. So when you add it to M1, you have your M2. So what is M3? M3 is when you add all those securities, like your short-term securities, but it's not you not add shares because they are called securities other than shares. You have some short-term instruments you can add on that will give you M3. So that's what you can be able to add to get the amount of money in circulation. It is when those things are increasing, that's what most central banks, especially Central Bank of Nigeria, try to look in order to see whether there's too much money in circulation. And then we have the end period of exchange rates. We all know what is exchange rates. When you try to know the amount of money, your currency can purchase based on other currency that you're benchmarking your currency, especially now what the only currency we benchmark it to is US dollar. So this is relative to US dollar. And I want to let you know that we have, this is actually nominal exchange rate. We have nominal exchange rates, we have real exchange rates. When you're using real exchange rates, you're trying to do that in respect to inflation. So when you remove inflation from this, you have your real exchange rate, and also have what is called nominal. We also have what is called nominal effective exchange rate. That is when you're comparing your exchange rate to different baskets of other exchange rates in the economy. That is nominal exchange rate. But when you're comparing your exchange rate to other baskets of exchange rates that you transact with, and then you bring in the aspect of inflation, that is really effective exchange rate. So you have to know the meaning of these definitions when running your analysis, because it helps for you to do your interpretations of your analysis. Then we have the Ocean Index, and then we have the OBB rate, which is called open repo rate currently. That is the amount, the rate at which commercial banks trade with each other overnight before going to the asymmetric corridor in Nigeria. So most times the OPR mirrors, it actually shows the amount of liquidity in the commercial bank. So most time when the central bank change their rates, basically changing their rates, the OBB mirrors it, like works when the central banks change their rates in order to control the amount of money circulations through the commercial, through the DMBs. And so the DMBs, when they see the rate changes and the amount of money in circulation, they try to, the OBB is a market rate which actually fluctuates in order to capture these movements in liquidity in the banking system. So it's not, the OBB rates try to tell us, looking at the OBB rates, you can able to know whether there's too much money in the banking system or not. But I'm not talking about the broad liquidity. No, I'm talking about just the banking system. That is the financial system. You can call it the financial system. How the rates tells us, it can tell us, okay, like for example, when you see a rate, so when a rate is small in an economy, you can be able to tell, okay, there's not too much liquidity in this economy. But when you see rates increasing, you see the central bank keeps on hiking their rates, you know that they are trying to fight inflation or trying to fight liquidity, because there's liquidity in the economy. So that's how the OBB rates, or called open repo rates, works in the banking system. This is in the context of Nigeria. And then we have the inflation rate. We all know what is inflation rate. And then we have credit to private sector. That is the amount of money that DMBs could be able to lend to private sector in order for them to boost the economy. We expect the credit to private sector to be high if you want economic productivity. We expect DMBs to be able to lend more to these private sectors if you want. So most times we try to look at it also to look at the level of money in circulation to actually use it too. So if the central banks hike their rates, they expect the credit to private sector to reduce because they don't have much more money to give to private sector. But if they reduce their rates, we expect the credit to private sectors to increase. So we have the government expenditure. This from the fiscal side, how governments disburse their cash or for developmental issues or to bring development. So this is the variables you're going to use. So as I've taught you, you can actually, this is January 2010 to, okay. So what I will name it, so this is how you do it. You go to new, you go to work file, then you know what we are using currently now is monthly data, no more quarterly. Then you can go and check the data set. It says January 2010. So you come here, you write January 2010 down to when is the data we can see it's I know it's September 2025, but I just want to be sure so that I won't make mistake. So you just wrote down, please just be patient. um I just wrote down, okay, so I think I've seen it. September 2025. Yeah, so write September, write Sep or something, September 2025. So yeah, I'll write um OLS underscore Umerich. Marriage. Okay. Okay. So it has shown in 2010 MO1 to 2025 MO9. So if you picked it, so what you do now, you go to quick, you go to empty group edit series. So this is where you put your data files, the file you're going to copy here. So we can just write, okay, we can just name our variables so that it will be easier for us. So the first variable is M3. Let's call it M3. Let's be sure it is M3. Yeah. Okay, so it didn't copy. Okay. Uh-oh, no. Are you sure? Are you sure? Okay. So I want to be sure. Let me be sure that the M3 is not written somewhere. Just wanted it to be easier. Okay, so what we'll do now, let's cancel delete on title group so that it will not give us issue. So we'll say empty group edit series. Yeah, okay, that's good. So we'll start from here. Or what we'll do, let's just copy the data so that it will not give us to not be an issue. So you just go here, as I taught you, it's better you pick the data by yourself so that you will not have any big issue. So we can just start here. We all know the first data is, and you pick it down to 2025. Just copy everything down to 2025. Then you go to your data set. You just paste. See, it's copied. So this serial O1, you can start changing them so that we'll have an alignment. M3, that's our first variable, say X. Then the second one, what is it called? The second one is exchange rate ESR, ESR, EXR. We change it. The third one as well, we say this all share index. You change it. The fourth one is what? What is the fourth one? What do you say is the fourth one? The OBPR. So we call it OPR. We call it OPR. OPR. And this one, I will show you every step. I will not cut any video. I will not be cutting videos. Most times when you watch different YouTube channels, you'll be seeing they cut the videos. I will not cut. I'll try to make it so that you can be able to understand every step, everything I do. You see, inflation. And this one, what is it? Say CPS. That is credit to private sector. So it's better you name like so to different mnemonics that you understand. That the name you can be able to call the variables. You can just call it based on your own understanding. This it's your own, the way you feel you can be able to understand the variable name. So this is it. So when you can close the data set now, when you close, you can see the data are here now. See the ASI, the CPS, the ESR, government expenditure, inflation, M3 and OPR. So now we are trying to look at what's from the demand side inflation, what drives inflation. So that is basically the topic of this analysis. So based on if you've gotten this, the first thing you have to do, you can do your pre-estimation test. you click inflation, you click government expenditure, you click exchange rate. You can just hold your key and try to click all of them. You click your all share index, you click your M3, and you click your OPR, open repo rate. Hold your control key to click all of them. So you open as group, then you click on view, and you click on descriptive statistics. So this is actually a new EViews, new kind of EViews. I think it's EViews 14 or something like that. Let me check the name. Okay, EViews. Okay, I cannot actually see here. So let me check here. Let me check my old. I think it's EViews 14. Okay, so you have EViews 14 here. So what you're going to is actually EViews 14. So what you're going to do, since in other if you stand, you might not be able to see this descriptive statistics. You might see descriptive statistics here, or others you might not see. Or if you stand, you click here, you click on common sample, and then it shows you the descriptive statistics of this variable. You can see the descriptive statistics. So this is how you do it in EViews 14. So this is it, and this is your mean, this is your median, this is your maximum, this is your minimum. So you can be able to tell your story from here. Your inflation, you can see from your inflation, you can see do you have 188 observation, which is actually good for the time series analysis. So mean, you can see we have 15.32. This is the mean. Government expenditure, you have almost 40, almost millions. Yeah, that's the mean. I think it's up to a million or 41,413,366.5 for government expenditure. Exchange rate, you're having about 431. Credit to private sector, you're having this amount. All share index, so which means this all share index is in volumes. You can see the amount. M3 is also in volume. And then OPR, open repo rate. So you can see their mean, you can see their median, you can see their minimum values. Government expenditure, there was a time government expenditure was a minus. That's what it's telling us from the data sets we have. Then you can see the open repo, there was a time it was 0.89. That is actually interesting. So you can tell your story from here in 42. So you can actually phrase and name the descriptive statistics. Descriptive statistics. So since you've named it will appear here. So that is it. It's going to appear here. So you can be able to call on it anytime you want to view it. So now we've looked at our variables. We've seen that some of them are in volumes, and some of them are in rates. We can just transform the ones that are in volumes to rates. That is actually easy. You just log them. So for example, we found that government expenditure is actually in volumes, and it is high compared to most rates we are using. So we try to log them in order to make their units smaller, in order for us to get a good analysis from them all. So what we'll do, say log, we'll say lgesp, your command, you do equals to, you say log, and you put brackets, you call the variable gesp, you close it, and you click on okay, you see, sorry, you have to call a command name before it's called gen r. You click on gen r, and then you click. So they are telling you log of non-positive number, missing data generated. You click OK. It's telling you that there will be missing data in this new variable set, but that is not what you're looking for. But you click OK, and then you do the next one for CPS. You say LCPS equals to log CPS, you click OK. So create a private sector is there for you, and then try to look for that of the all share. I think the next one is the all share index. Sorry, let me click on this description so I can see them very well. So we have the next one is all share index. So you do Gen R, L, ASI. I think the cap there is in capital letter. ASI equals to log. Cover it. You say ASI. I click on OK. I believe it's there in our work file. Let's check. Let's verify. LASI, look at it here. It's here already. So the next one is the M3, which is the broad money. We can actually do the same for it. We'll say Gen R L M3 equals to log M3, and you close it. Yeah, it's gives you the same thing, LM3. So since we've gotten that, we can now check for unit root test for these variables. How many variables do we have? We have 1, 2, 3, 4, 5. Okay, let me count from the Excel sheet. We have 1, 2, 3, 4, 5, 6, 7. So we are trying to look how these variables affect inflation in Nigeria. So what we have to do now, we look for the unitary tests. Let's say we start from Ocean. There's you can click on it. You click on View, and you click on, the last time we checked, the unitary test was here. So you click on unitary test. You see standard unitary, level. We actually log the ASI, right? So the one we are going to do is the logged one, not the ASI itself. So this is the log ASI. So check on View, unitary, or maybe let me show you something before doing that. Let me draw the graph of both the log ASI and the ASI itself, so that you can be able to have a grasp of what I'm talking about. So this is basically the pre-estimation you can do for any analysis you want to do, any model you want to run, whether OLS, whether panel ALD or ALDL, whether VAR, SVAR, VECM. This is what you basically do. So you can see the movement of both of them. Log ASI, you can see how it's okay. Let me draw them in different let me put them in different uh, lines, so that we can be able to see for ourselves. Let's see, so that it's going to be much more easier for us. Okay, so got it. So this is log of ASI, and this is ASI itself. You can see ASI ocean, this how big it is, and now that we've logged it, it became smaller. We compressed it's like the stock of the volume of the data set became more compressed. So look at we were having about 2025, maybe we were having about 1 point something. It's about trillion, I would think so. But now, since we've compressed it, we're having something that we can work with that is easier for us. So that is the function of the logging. It makes it's as if it compresses it, so that when we are comparing the ASI, the Ocean index with other data sets, it will not be like much of as if you're doing a different thing altogether, because the volume will be so dispersed, and it might give you a spurious analysis. So that's just it for the graph. You can also save this graph if you want to, in order to tell your story about the reason why what you do or why you didn't. You can just freeze it and also name it. You can just say graph of ASI. What I love about EViews is that they give their graphs are actually nice and beautiful. So that is that. You can do the same for other data sets. So now we can actually look for the unit root of um, log of ASI, go view, and you say unit root. We looked at it here. Unit root, standard unit root, level. You can click on it. Okay, it's telling you that it is not significant at level. You go to view. You click on unit root at uh, first difference. Let's see, it's significant at first difference. So you can freeze and you name and you say log of ASI was significant at I1. You can just name it like that. Then you save it. And then the next one you have to check is let's say credit to private sector. We also logged it. You click on view. Uh, we check for the unit root tests. And we saw, okay, let's check for level. And then we saw that it's not significant at level. Then we go to view. We go to time series diagnostics. We go to unit root test. We check again, and for this time at false difference. And we saw that it's significant at false difference. You can also freeze and you name. You say credit to private sector was significant at I1. That's it. And the next one is you check for which one do we have to check next? Exchange rates. We didn't log it, so you go view unit root test, and you check unit root test at level, and then you when you check at levels, you can click on it, and then when you click on it, you can be able to see if it is significant or not. So when you look at it, you see that the unit root test is not significant at level. So since it's not significant at level, then you check for it at false difference, as we did for the other ones. And when you check at it for false difference, when you look at it and you see that it is significant as false difference, then you freeze and you name it and you say ESR I1. You understand? So that's it. And that's for how many variables now. You can count how many you've checked. One, two, three. We've checked for 1, 2, 3 variables. So it's remaining 1, 2, 3. So it's remaining 4. So we've checked for ESR. Then government expenditure, we actually logged it. So we are going to check for the log of government expenditure. Click on view, then click on unit root test. We click on unit root test at levels. What are we seeing? We saw that it is not significant because it is higher than 0.05. Then click on view. You click on time series diagnostics. You click on unit root test, and you click on false difference. And you saw that it will see that it is significant. Then you freeze, and then you name it. You say log of expenditure at I1. So that's it. So it's remaining about how many we've done. 1, 2, 3, 4. So it's remaining 3. The next one is inflation. Inflation is in rates. So go view. We'll click on time series diagnostic, unit roots, standard unit roots, level. Looking at it, you see that it's not significant. I don't know, Nigerian data, the unit root test for inflation is always significant at false difference. So they say unit roots, standard unit roots at false difference. What do you get is significant. So what you say, you actually freeze and then you name it and you say inflation I1. So that's it. Then the next one you have to do you have to do. We've done inflation. So how many variables have we done? We've done 1, 2, 3, 4, 5. So it's remaining 2. So after inflation, the next one we have here was, I think we've done ASI. The next one we have is M3 and OPR. So we logged M3. So we use the log of M3. We look at view. We look at the unit truth test. Unit truth test at level. What did we see? We saw that it's not significant. Then we'll try another one at false difference. We'll try it at false difference. What did you see? Is significant. So you say you freeze it and then you name it, which is lm3 underscore I1. You can see I'm doing the same thing for all of them. And the last variable we have here is the open repo rate, which is the OBB. So we do view unit truth test. We check for it at levels. You see it is significant at levels 0.01. So most times, um, there's always a saying, like if you read, if you want to do ALDL, there are some authors that say you have to have a combination of I1 and I0 for you to do an analysis on ALDL, and then for your underlying least square, you have to have you have to have your variables to be stationary all at levels or all at phase difference for you to do your OLS. And then for your var, the same thing, you have to have your variables to be stationary at levels or stationary at I1 for you to do that. But most times, some authors too, when you read some authors actually don't really pay attention to the unit root test because of the issue of some data sets. Some data sets actually have issues, especially when it comes to Nigerian data set. So, but this is for academic exercise. I will when I'm running the unit truth, the when I'm running the analysis, I might just leave open repo rate out of it and run analysis on the other variables for me to explain things to you. But after that, we can still include open repo rates for us to run our analysis. But if you want to conform yourself to any of the school of thoughts about unit truth tests, it is okay. But as for me, I try to clean what we did. We've cleaned the data, we have adjusted and make sure that they are stationary. That is my own view when it comes to running unit truth test. Just make sure that it is stationary and you do your analysis. So you can click on view since it's stationary at levels, but we can actually check what it will be if it's stationary at false difference. So what I would do when I want to take you on ALD, I'll put the OPR into the equation for it to be an autoregressive distributive lag analysis. You understand? So now let's just check for first difference and see what it's going to give us. It is also very, very stationary. So now what I will do, I will do view and leave the answer in I0 so that it will be easier for us when we want to do the ALDL test, the ALDL model. So okay, so it is stationary at 5% and 10% level of significance. So you can freeze and then name the variable OPR I0, OPR underscore I0, so that we can use it to make our differences in our analysis. So now we've done the unit truth test. What we need to do now, okay, we can actually draw the graphs of these variables that we use, excluding OPR. So now we are using all these 6 variables in the analysis. So let's start from inflation, log of CPS, exchange rates, log of expenditure, log of all share index, log of M3. Is it up to 6? 1, 2, 3, 4, 5, 6. Okay, it's up to 6. We'll open as group, and then what do we do since we've opened it as group? Then we'll say view, and then we'll say graph. Let's look at the variable. Okay, you can see we have the issue. What is the variable? Exchange rate is the one that is appreciated. Okay, let's see whether we can make it better by changing the angles of the graphs. Let's see how it will look like. Axis and scaling, since other variables are, let's look at it and see how it will look like. No, right. Okay, so let's see how it will look like. Okay, still okay. So maybe we'll just draw the variables based on okay. Let me just draw the variables because it seems the variables are much. Let me just use the rates. Let me use inflation and the various rates that we have. Inflation, exchange rate, open repo rate is out of it. Okay, let me just include another variable like uh, log of SI. Let's see how it will look like. Let's look how it will look like. Let's see how it will look like. Okay, so the exchange rates is still up there, and then so let's view graph, axis and scaling, inflation. Okay, right. Which other variable do we have here? Number 2, which variable is this? Okay, number 3, right. Okay, so we're able to get something when we plot them in different angles so that inflation, looking at it, you see that exchange rate is what is driving, actually drives inflation a lot. You can see inflation makes exchange rates. Okay, let's try another variable. Let's see, let's add another variable. Okay, let's just add all of them and see whether we can just move all of them to the right and leaving only exchange rates in the other angle. Let's see whether it's going to 1, 2, 3, 4, 5, 6. Okay, open as group, view, graph. You understand, axis and scaling. So this one, okay, this is inflation, move it to the right. This is exchange rate, we'll leave it where it is. This will move it to the right. This will move it to the right. This will move it to the right. And M3 will move it to the right. Let's look at the data set. Okay, so let's see what it's gonna give us. Okay, this makes sense. So now looking at it, what's this variable? This variable look like a log of expenditure. Okay, this one is a log of ASI. These two variables, what are they? Credit to private sector, and which one is up here? M3. Wow. So credit to private sector and money supply, they actually move alongside, they mirror each other a lot. So this is the variables we have. Exchange rates. I think exchange rates with these variables, they actually drive inflation up. I think that's what this analysis is trying to say. So this can pass for your style last part. Okay, and you can also check for period before we have 2010. You can actually check for period before COVID for you to understand the data set a lot. You can say before COVID, what let's say COVID started the 2019 M12 before COVID. You can be able to tell a better story from it. You can look at it and you see a better story. The movements of these variables. We can see that government expenditure has always been fluctuating, but fortunately it's actually locked, so it's actually been fluctuating. I don't think it's driving. According to it, there's no spike to say at this period it's actually increased uh, inflation a lot. Okay, let's see. Let's include till 2012 when inflation was we had inflation. Let's see whether okay government expenditure still didn't increase, but it's increased when you compare it September down to it's as if it's on a steady path actually. So the main increase we've been looking at seeing is in exchange rate. That is, our exchange rate has been depreciating. That's what it tells us. Because in the Nigerian context, if exchange rate falls, is appreciation. If it's increasing, it is depreciation. So we can see that our exchange rate has been depreciating, showing that it has been the cause why inflation has also been increasing. And our Ocean index is still on the same path. So the major movements we are seeing is in the exchange rates, but maybe because of we didn't lock the exchange rate, so we can't really say the inflation. We didn't actually lock, but these other variables we actually locked them for us to get a more concrete analysis. Okay, but that's that for the whole. So we can look at after COVID to date. Let's say 2020 M4. 2020 M12, 2020 M12. Now, let me increase the so that we can be able to see. Let me close this command. Let me see if it's going to, so that it's going to be broader. So you can see after the COVID, what is happening to our uh, demand side inflation. You can see inflation has it's increased, but currently in September, maybe due to the increase in MPRs and the rates, it's dropping. I would have included the OPR, but since it's not significant, it's significant at levels. I just want to make obey some instructions of econometrics so that all the variables are stationary at I1 so that we can be able to run our OLS. So this is our results, and let me just go back. Okay, let me just increase it back. No, let me just increase it back to where the way it was before. So these are full data sets. These are full data sets. So let me just take it back and continue from where we stop. See if you have beautiful pictures that you can use to tell your stories. So getting to know the how the graphs moves and we've done the unitary test, we can just move ahead to run our analysis, do open as equation. So when you go here, EViews, the constant is at the end. EViews can give you different options on how to run your analysis. It's always on least square, that is the OLS. You can run other analysis, you can run the ALD, all of them are here. Your VAR, except your VAR analysis that you have to run it with a different command. But these other variables, they are all here. You can run anything you want to run with it. So this is our least square. So it's still 2010 to 20. Here you can also try to look at it different different dates. You can change it here to look at it. Okay, let's just look at the full dates. Look at what our result is telling us. The result is telling us that though we have issue of autocorrelation with W, Watson is actually less than 2. It's supposed to be approximately 2, but the model is robustly well stated that based on their statistics. And the R square is 81%, which means independent variable explains the dependent variable. And our adjusted R square is 81%, means that our R square, our adjusted R square is also robust. So what does this analysis tells us? It tells us that all the variables actually is significant at 1%. You can see that exchange rates has 0.0 has a positive relationship with inflation, which means it increases inflation with about okay, both of them are their in rates is about let's say 12%. If you times with 100, 12% is explained by so Ocean index actually reduces inflation. So if there's a lot of stocks, if there's markets, Ocean index increases, you expect inflation to increase. That is if our Ocean index, the prices of our Ocean index increases, you expect inflation to reduce. That's what this result is in. Then credit to private sector. If you keep on increasing credit to private sector, if there's much credit to private sector, you expect the credit to actually because the explanation should be in the explanation you're going to be giving. It should be in a linear log model, linear log structure. So um you're supposed to divide this by 100 in order to get explanation. So you might be saying that Ocean Index reduces inflation by about 0.42, something like that. And looking at credit to private sector, you see credit to private sector actually increases inflation. You might be saying it's increasing inflation by about 0.15 or something like that. And then government expenditure was showing to also reduce inflation, which is not theoretical. It is against theory, but our result is saying that the more government expenditure increases, your inflation reduces. This is against theory, so there must be a reason why this is so. And then LM3 was telling us that the money increase in money supply actually reduces inflation in Nigeria, which is also not theoretical, which means there's an issue with something or there's something maybe there might be a structural issue or something. So that is where you lay your analysis on, you tell your stories on. So there's something I actually want to show you based on this. We can actually go to residual diagnostics. Um, I want to look at the residual series for us to tell some stories about it. The residual redundant test, what test, residual. No, this is for the post estimation test. Um, actual fitted residuals. So you go to actual fitted residual graph. You look at it. We can see that our residual there's an issue here. It came up the movement of our residual, how the actual data, how actual and fitted is. You can see the movement, how it is at this period from 2011 down to 2016. There was a much drop. You can see it doesn't move very well. You can actually, in the next class, I will show you how to correct this so that it can be able to, most times it's due to structural breaks. Structural breaks are what causes this. From 2011 down to 2015, it was really, you can use structural breaks to correct it. But since it's moving like this, okay, let's just say it's have almost the same structure. It's most times if there's a structural break in this variable, you can see that it might move up, it might go move up and then go down and then move up and then for being fitted. So looking at it, you can see that there was a slight fitting in the variable sets. So that's okay. So based on that, let's look at Oh, did I? Okay, I close it. Okay, I want us to look at. I can just run the analysis. Next time you can name it so that it will not really leave the spot. So this is it. So we can actually change the time frame to us to look what is, because this is the full results from 2010 down to 2025. We can actually change it in order to see, let's say before COVID, you change it to let's say 2019 M12. So let's see how the result will look like. And then you compare. So looking at it, you can see it's about 57%. There's the independent variable explains the dependent variable by 57%. And then we can still see that government expenditure on M3, but government expenditure was not significant in this. So which means if you include more data sets, it also helped to make the variable significant. So looking at this, it still shows that it has negative impacts. Both of them have negative impact on inflation. Ocean index also have a negative impact on inflation. But exchange rates, credit to private sector, exchange rate and credit to private sector are what increases inflation. Okay, so let's look at a different sample size. Let's say, let's look at, this is our full sample size is to 2025, right? It's to 2025 September, 2025 September um 09. So let's look at 2020 and 12. M12, let's see what it gives us. Okay. So this is after COVID. After COVID, we saw that the same ocean there's government expenditure and M3 also showed to reduce inflation, but exchange rates and credit to private sector also increases inflation. So we also saw that exchange rate was significant, ocean index was significant, all the variables became significant. That is after the COVID. So after the structural shock, we saw that, and this actually the dependent variables to even explain the variables very well. So, but there's still issue with this autocorrelation in the analysis. So that's it for today. I think we can just run it back to our normal data 2010 M01. So that's it for today for ordinary least square.